Hello, hello, and welcome to Kinetic Architecture for Unreal Engine 5 course, Part 2. If you haven't seen Part 1, I strongly suggest you do so because we'll be building up on the geometry as well as the blueprints that we have created during Part 1. With that being said, I'll give you a quick rundown of what we are dealing with right now. So in Part 1 of this course, we have created this single blueprint which has 3 gears, 3 poles. Well, poles are basically connected to the gears, or columns are connected to the gears. So basically gear A, gear B, gear C, right? And we have 2 sticks connected right at the top of them. And if I press the F key, the gears spin, and the sticks correspond to the movement, to the spinning motion of the gears, right? That was the basic principle. Already at the start of this video, I have shown you the final result, right? So you already know what we're aiming towards. I'm not going to explain that, but basically for this second part, my goal is to create something a little bit more aesthetically pleasing and also create a workflow where iterating through the designs of what kind of architecture is attached to these poles or to these horizontal sticks, iterating through those would be as painless as possible, right? So I'm going to showcase one trick there for you. Also some materials, but that's later. Okay, so now the first step is actually to model out, something that's a little bit more visually interesting and also something that is a little bit more true to life, meaning that maybe the horizontal elements here shouldn't be floating, but they should be actually be held by some sort of a element that has the possibility to rotate, right? Since that is going to be a modeling exercise, and this is much more of a working in Unreal Engine blueprints and importing and so on kind of a course, I'm going to do a time lapse instead of me explaining all of the thought processes behind the 3D modeling. So let's do a time lapse. So now we need to get these into Unreal Engine, right? And one thing that my students actually showed me, and I didn't use that before, but now I'm going to be using it for everything, is a command that's called export with origin. So it's not just export, but export with origin. That command enables us to export things without actually needing to place them on 0, 0, 0 coordinate, which is very, very convenient. So for instance, this guy right here, if I let's hide this. Come on, hide that, and hide that. Okay, this holder right here has this little pivot point. And of course, the holder itself would rotate only around this pivot point, only around the z-axis. We will need to take care of that. We'll need to figure that one out. But the pivot point it should be its origin point, right? So we need to export it with this being the 0, 0, 0 of it. How do we do that? Glad you asked. We simply select it, type in export. Oh, sorry, my bad. We select it, we type it export with origin, muscle memory. Export with origin, hit enter, and then it asks us to give it a point. So I click on this point and I just name it, if it's gear B, then it's going to be holder B. Holder B. There we go. We hit save. Should it be, yeah, more polygons, doesn't matter. And now we should technically have it in, well, it should be very easy for us to import it into Unreal Engine. So now gears for tutorial, holder B, drag and drop in as per usual, build nanite, enabled, import. Close that. We have our little holder now in our blueprint under viewport. Let's see where it should live. So I guess if I just simply, first if I just simply get it in here, so add static mesh just to my default scene root, and I'll just call it holder B, holder B, and I choose it in my static mesh rollout right here, holder B, there we go. Of course it gets located at 0, 0, 0, that's normal, as it should. Okay, so then I need to place it, or I need to connect it to my gear B top point right here. Let me find it. There it is. To my gear B top point. And its rotation is going to be out of whack, be ready for that, but the placement of it should be fine. So holder B connects to gear B top point, like so, and its location needs to be reset, right? So I click on this reset button. Now it's here. Oh, actually, yeah, it just so happens that the orientation is correct. If I compile, save, and I press play, you'll see that right now it's okay, but the moment we run, its rotation is off, right? That's fine. We will fix that in just a second. Let's get holder B also on our gear C, because I think it's gonna be the same size. I don't remember. Let me check. So in my Rhino file, feels like it's correct. Yes, Bounding box says that it's at least in the same height. So that should be correct. So let me just try this little trick. Holder B, Control C, Control V. So now we have 2. And just drag this over to gear C, which is this, top point, which is this. And I just connect holder B1 to the top point, like so. Of course, reset again. And let's just rename it to holder C, of course. Holder C. Okay. So now clearly you can see that it's wrong. It's out of whack, and it shouldn't be like that. And it's all it looks all funky. And at least this will enable us to find correct way of how to determine the angle for both holder C as well as holder B, right? So let's do some math, or let's figure that one out. In our construction script, and we will use construction script, we will set not the transform, because the transform is driven by the point, right? But we will set the rotation. So set relative rotation. I'm not sure if it should be relative or world. We'll figure it out. So let's set relative for now. Set relative rotation. Gear B. Come on, no, not gear, holder B. Okay, for now, set relative rotation. This is gonna be faster. I'm just gonna get that, and then I'll just drag it from here. Holder C, this one, this bad boy right here. Drag and drop, connect, easy. You drag and drop it in to reference it, right? And now by doing this, I can set any number as for the rotation. So let me break rotation or make rotator. I'm sorry, make rotator, like that. And now it has like the XYZ coordinates for the rotation, which means that I think I can just simply give it like 90 degrees, compile, and in the viewport, I'm not sure if it changed anything, but let's give it like 45 degrees. So then it's going to be aligned somehow with the pole. 45 viewport. Yeah. It does change. Okay. So back to 0. We need the proper amount of degrees, of course, clearly. Right? Thankfully, we have our way of how we determine the angle, right? Because we can get, let me actually build this for you one more time. So what we can do is we can get this point right here, which is gear A center. No, sorry, gear A top point, this point right here. We can get gear C top point, this point right here, and we can determine the angle between the 2 points, right? Yes, we should. Clearly, it's gonna be that simple, right? So gear A top point, get world location, easy. Gear B top point, nope, making a mistake. Gear C top point, where we're dealing with the C one, right? Holder C. Get world location. So we know where these two bad boys are, where these 2 points are. And now with these, find, look at rotation, right? Find, look at rotation. From A towards C, we get a rotator. I can actually show you what happens if we just simply take this rotation and just slap it in here. like that. Compile, viewport. It's kind of rotating weirdly, right? And the reason is because this geometry needs to only rotate around the z-axis, right? It should not, yes, it should not rotate around x or y. So in the construction script, I'm just going to, from this, I'm just going to break rotator into its x, y, z values. And I'm just going to yoink the z value and make a rotator. So it's always going to have x and y set to 0, and then we connect it to the rotation like that. Okay, you with me? I hope that you're still with me. Right, get A top point, get C top point, find the direction, find the rotation between them. By the way, it finds the rotation assuming that your starting rotation is aimed directly at the x-axis. So any geometry that you do, that you make, needs to be oriented towards the x-axis. That is the front-facing direction, right? The red arrow in your Rhino file is the front-facing direction. Very important. And it's going to kind of snap it in place, technically. Also, it's weird with that y. Don't worry about that. Anyway, compile, viewport. Yo, you wanna explain to me what's up? Gear A, gear C. Are we looking at gear A, gear C? Oh no. For some reason it really wants to be rotated 90 degrees. I don't understand why. I'm gonna check. Yeah, it is aligned properly. X is there. Okay, give me a second. Okay, I figured it out. We're back. So the lookout rotation is not relative, it's global, meaning that it kind of gets the rotation according to the world axis and not the local axis. So that's why we use set world transforms here, and that is why we need to set not relative rotation but set world rotation, right? So this gets deleted. Set world rotation. Bam, holder C, get that rotation in there, compile, save, viewport, bam, works. Okay, back to construction script. Let's start cleaning things up a little bit because this is getting a little bit too much. So I'm just going to take this group and I'll just hit C and I'll just call it C, like comment. C button. So you select all of them, press C. And let's name the group that is going to be stick one movement. Like that. This one, C, stick two movement. Great. And that one, C, this is holder C movement. Now we're gonna do holder B. So to do holder B, I'm just going to basically select this, copy paste like that. That is weird. Let me try that again because that was strange. Copy paste, there we go. Now it works. No, it doesn't. Am I missing something? Wait. There we go. I'm not sure why copy paste was freaking out. Anyway, This one will be named F2 to rename things, holder B movement. And our holder B orientation is gonna be, it starts with gear, it starts from this point, then it goes to gear B top point right here, right? And then, yeah, that's it. So everything that is C becomes B. Nope, gear B top point right here. And that is going to be holder B. Just like that, easy peasy. Compile, save, viewport. Nothing freaked out, nothing freaked out, great. So that's our construction script, right? Seems to be working a-okay. And now we need that in our event graph as well, which also kind of needs a little bit of cleanup, or no? Yeah, we're gonna make some comments here as well. So I'm just going to stick 2. Sorry, I'm just gonna be real fast about this. Stick 1, like that. And let's just get those two, holder C and holder B, in there. So I select all these two groups, Control C. I go into my event graph, Control B, Control V, and I just connect the trigger wire coming from set world transform into set world rotation. And technically this should work because this is all that we wanted to do. Let's press play. It doesn't seem like it's messing up. That's good. F. Oh yeah. Working as intended. Okay, so that is the logic. That is the way it should be. Which means that now we can mess around with the shape as much as we want. We can change its form. We can detail it like crazy, change materials, blah, blah, blah. It's always going to update, and we only need this to basically update this static mesh right here. Wonderful. That's what we want. Now, we need to figure out holder A situation, because our holder A is now actually 2 holders. these two guys here, meaning that, yeah, there's gonna be a little bit of a situation between these. That's fine. We'll figure it out. So for now, let's export these two, right? I'll just hide as much as I can. Okay, so this one, export with origin, this point, and I'll say holder A lower, like that. Okay, and then we export this one as well, holder A higher. And there's going to be, of course, now 2 points, not 1 point, that will serve our whatchamacallit. I'll get there. There's going to be 2 points in our center core, not 1, because right now, if we look at it, it's 1 point, so we'll have 2 of them, right? The endpoints of these will be separated. That's fine. We will take it slow. We will do it. First step: import the exported holders. Holder A, holder higher, and holder A lower. Import. That's easy. Get them in here. They exist. Now, under our blueprint, where we have our gear A, let's find gear A top point. Let's check the location. So 60.125 and 436.224. Let's check if we have those coordinates somewhere here. What? That is absolutely not that. But wait, it shouldn't be that, right? Because that is relative to the center point of the gear. So it shouldn't be that. So what we need to do, we need to actually create those, since we're rebuilding this part, let me create two scenes at these coordinates. So 1 point and 2nd point, I want to create those again in the blueprint. And that's just going to be good practice for you guys as well. So in the notepad, I like using notepads for copy pasting things. This is going to be my lower point coordinates, and this, type in what, is going to be my higher coordinates, higher point coordinates. There we go. Why are they, oh, never mind, they are not the same. That's good. The Z is different. Okay, so now I'm just going to create under the default scene root. Keep in mind, you always create these points, you know, that you get the coordinates from. You create these points from your default scene root. That's important. So you select default scene root, add scene, and I'll call this gear A lower, gear A lower point. Well, I should call it point, but doesn't matter. Actually, it does. Lower PT. There we go. Lower point, right? And I add those coordinates right now into it, just like so. Come on. So bad at this. Wait, I can't. Why can't I? I can right here. That's weird. Okay. Oh my God. Discord, shut up. Copy. Oh, there we go. My bad. That was weird. Get that in here. And finally, get that in here. Okay. So we get our point that for some reason is way off. I guess the y-axis needs to be positive. No, it doesn't. I actually dug my own grave by creating this world placement scene into which I've added all of the other elements, right? So that I could have an offset inside of the blueprint. You shouldn't do that, right? So I guess, I wonder if I can just delete it. Yeah, I can just delete it, and now it's gone. Anywho, when that is, so on your screens you should have a proper placement. It's just that I have created this additional scene in which I packaged everything and I had an offset on it and it drifted the point. It actually wasn't a problem, right? So on your screen it should be completely fine because you didn't have the offset to begin with. Anywho, we're back on track. The coordinates are exactly as in our notepad, and it's placed right where we expect it to be placed, right? Right here. So that's our gear A lower point. I'm going to make a copy of it, and it's only connected to the default scene root at this point, right? So the parent of this is the default scene root. I'm gonna Control C, Control V it to have gear A lower, gear A higher point, higher PT. There we go. And this one will have a different Z value, 487. Nice. Let's go. There we go, a higher point. Great. Now we have these two coordinates, and all I need to do is just grab them both and just drag them into my gear A center, right? Because they need to rotate around gear A center. Like that. Bam. Now, this is gonna be weird. Gear A top point is currently being used by multiple elements in my script, right? In my blueprint. So if I remember correctly, I can just simply, if I just select it and delete it, never mind. It just breaks everything, which is fine. Okay, so just delete your gear A top point. That's fine, because we'll be using gear A lower point to replace whatever we had before, or gear A higher point, right? So don't worry, we'll make it work. we'll make it work. Okay, I do need to check one thing. Just give me a second. So lower connects to that and higher connects to that. Okay, so the lower point should connect to the B, gear B top point, and higher connects to gear C. So higher to C, lower to B. That's important, an important distinction. Okay, so immediately forgot lower to B, right? So gear B top point connects to gear A lower, like that. Let's just check. This is going to be stick 1 movement, compile. Oh yeah, it's gonna, yeah, okay, it's gonna freak out because all of these don't have anything. So we actually do need to connect everything properly. Okay, so gear A lower point to B, then gear A higher point to C. That's easy. Gear higher to C and lower to B. Compile. What? Oh right, the whole event graph is freaking out. Okay, so that's the same. Lower to B. By the way, I will make all of the files available to Patreon supporters as well as the students in the course. Higher to C. So check out the link in the video description if you are not one of the students. No, C needs to be higher. Lower. There we go. Yay, working. Yay, working. Everything is working, right? So what we did was basically just create separate, not create, separate 1 point into 2 points and make lower point connect to the top point here, right? So we're using this as a pair, and the higher point right here connect to top one here, right? And everything still works. Yay. So now it's time to get these bad boys, get the holders in there. Okay. So gear A lower point. Just going to add a static mesh to it. Is that smart? Yeah, that's how it should be. And holder, I'll call it holder A lower. Easy. Static mesh, holder A lower. Perfect. Beautiful. And gear A higher point, again, should be easy. Add static mesh, call it gear A higher. Oops, holder A higher, not gear. Holder A higher, and here we just choose it. Bam. Question mark? No. No. What did I do? Oh, for some reason, this one has an insane offset right now. So I'm just going to reset it to 0, and now it's happy. Now it's fine. I assume holder A lower. Okay, holder A lower does not have an offset. So that was weird. But hey, it works now. Of course, the alignment is wrong. I wonder if the alignment can be solved by reusing the exact same movement for... So if we're rotating holder C, that means we can also rotate holder A higher, because those two need to share exactly the same angle, right? In Z. So can I connect two? It does not look like it. Okay, holder B and lower. Compile. Okay, so that works. So I wonder why holder C does not work. Is it because yeah. Okay, I understand why it doesn't work. Notice how this element right here is not aligned with the x-axis, right? As I was modeling this element, I was modeling it already in an active state, right? So it's not aligned with the x-axis. How do we fix that? We need to fix that. Well, we need to figure out... I mean, I think it would be enough to just copy, make a copy of it, select objects to copy. I copy this element, enter. No, sorry, I take that back. We rotate it. We will rotate it to be aligned with the x-axis, right? So select objects to rotate. I rotate this bad boy, enter. Center of rotation, copy. First, I choose yes. I want it to be a copy. The center of rotation is going to be its origin point right here. And then, since I have this line, I can kind of use it to specify that, okay, so along this line, I want to start rotating from this line, and then I want to rotate it until it aligns with the x-axis. If you don't have the snapping tool turned on, or orthographic snapping turned on, do so. Either F8 or Shift key, holding the Shift key. So I aligned it with X. X is the red arrow there. Or in the bottom left of the screen, you can see where it's aiming at. Align, click with your mouse, and now we have an... Let me clean this up, isolate. We have one element that was rotated and that is now aligned with the x-axis. I think that should be enough. Let us select this, export with origin, select the origin, and just simply replace holder A higher. Save, replace, okay. Back in here, under our map, I will right click my holder A higher here and choose re-import. See, it kind of got rotated. If you haven't noticed that, rewind 5 seconds, you'll see that even the icon gets rotated. And now here, now it's aligned. It's good when things work. Okay, back in the event graph, it's time to actually also figure out the connection. So holder A lower with holder B, holder A higher with holder C. Okay, that should be easy. Bam, like that. Like that. Compile, save, play. Oh yeah, I forgot that I removed the world offset, so we'll need to fix that. But for now, let's find a way. Actually, let's move this down to somewhere here, like that. And then I move on top of here so that we can see better. I know there's a better way, but okay. Looks mechanical. Looks mechanical. Looks like it is working. Looks like we are happy. What time is it? Should go to sleep. Of course, the video you'll see. Check out the length of the video. After I've slept, I will do more because I want this to be the final part of this portion, at least of the kinetics course. Let's do one more. I'll show you how I will re-import the sticks. So that's done. Show. Oh yeah, and I don't need it anymore, so I can just delete it. Oops, deleted the wrong one. Delete that. So these four are done. It's time to import the stick, right? And in case of the stick, it's going to be basically this, right? Or no, it's going to be, sorry. It's going to be these bad boys, right? So they are going to have, they will need to be aligned properly. Sorry that I'm speaking with to myself awkwardly. So for this, I suggest using Grasshopper. I know it went 0 to 100 real fast when I mentioned Grasshopper, but I do suggest using Grasshopper. The reason is we want to have things aligned properly, and multiple orientations might induce some mistakes, some issues. So it's better if you just do it with Grasshopper instead, to eliminate potential for mistakes. Okay, let's select the origin point, which is right there, right in the middle. See? If you can't select the origin point, just go to wireframe and then fish it out, or even better, have it as in a separate layer, like that. Let's select the holder, secondary holder, or the sleeve. We'll call it a sleeve, and just isolate those. Okay, so that's the sleeve on the holder. And now we want to be able to export this, right? With basically this direction. Come on. This direction being set as X on the X-axis, and this direction being set on the Y-axis. So I'm going to type in Grasshopper. We're gonna use Grasshopper for that. And it's going to be 3-point type of a orientation thing that we will do. So let's say geometry, set one geometry, this sleeve right here, and I'll use orient, orient on object. That's perfect. So that's the geometry that we're going to be orienting. Let me do bifocals. I know that you're maybe not new to this, so and this is only for those of you who use Rhino, right? So we do bifocals to show you the names of things, and also I can help out with drawing full names. So geometry is going to be oriented. The source plane, we need to construct plane, or rather let's go to vector plane and just find a way. Yeah, plane between 3 points. That's going to be useful. Okay, so origin point is clearly this point, set one point, bam, it's there, just connected. Another one point is going to be the x-axis, right? So that needs to be the point B is x-axis, if I remember correctly, and point C is going to be right here. Point C. Yeah, and we get a plane. And you can double check if your axes are correct. You want the red boy to be along the line, the length of your sleeve, and the green boy to be along the like cross towards the joint of your sleeve, something like that. And you use that as a source. Then you can see it right here where you want it, and then we just simply insert, right? Press the insert key, or you can right click, bake, and then choose the layer in which you want to bake it, but then you have it here. Okay, so we have a very simple script that enables us to orient things, right? And I'll hide the preview of it. Okay, now this gets exported. Export. This was sleeve B. Sleeve B, save, export. And then back in here, we just drag and drop it in. Bam, imported, right? So it's oriented properly along the x-axis, so that if we need to reorient it, we can do that very, very easily, which is very, very nice. That's the whole point, right? Okay, so now back to my blueprint. Under viewport, we need to get that sleeve in here. So default scene root, of course, or no, the sleeve gets connected to also the same origin point. So gear B top point, add static mesh, and yes, sleeve B. Little trick, when you have selected this static mesh, so you just kind of highlight it. If you're creating or if you're adding a static mesh, it's already going to be referenced, which is very nice. And you can see it's already there. The orientation of it is bad, so we need to fix that. So this one actually needs to rotate the whole way, right? I think so. Okay, let's see. No, it only rotates around the y-axis. So in our construction script, there does need to be, unfortunately, there will be two more groups of things that come on, that will be driving things. Groups of things that will be driving things. Come on, I can do better than that. Since copying groups is really problematic, I'm just going to really quickly create a fresh, not script, but like I'll just replicate this one more time. So gear A lower point, then gear B top point. And that's stupid. I mean, this should work. Yeah, it just works. I don't know why it sometimes doesn't work. Lower point, top point, get the rotations, and instead of Z, we will be rotating around Y, because if we look at the viewport selected, that's the Y axis, and that is where the restriction for this rotation is, right? So like that. But also it rotates around Z, right? Because it's technically we can do it in a very kind of funky way, where we connect the sleeve to the joint there. Sorry, we connect the sleeve to the holder, and that it inherits the movement of the holder from and then we don't need to write it. Well, that doesn't matter. The sleeve does rotate around Y and Z. It does not roll, so we make it like so. Sorry that I'm blabbing. I'm starting to get tired, I think. Set world rotation for sleeve B. Perfect. Don't forget the trigger wire. And get the angle in there. Compile, save. Don't play, just check in the viewport, and it aligns properly as you want it. Okay, so that is the name of the game now with all the remaining ones. I wonder if we can get away with having just one holder. Are all of these the same? I don't remember how I modeled them. I spaced out. These almost feel the same size or proportion. I'll assume that I was smart about it and all of them are just holders B. So I'm going to make all of them holders B in here. I'm going to use the same geometry. So for top point here, add sleeve. I said holders. I meant sleeves B. So that's going to be sleeve C. That is using sleeve B static mesh. Okay. Then for gear A, lower point, add sleeve A lower. For gear A higher point, add sleeve A higher. There we go. So we have a mess here, except for some reason sleeve A higher is with a huge offset, which we reset right here. So this is fine, that's fine, that's fine, and this one is already fixed. Okay. Okay. So if this is fixed, that means this can be fixed, right? In exactly the same way. So sleeve B and sleeve A lower share the same rotation, just like here, just like the holders do, right? Compile, save. viewport. Yep, that is a beautiful connection right there, just like in our Rhino file. Nice. And then I'll just do it this way: copy, paste, connect, delete all of the inputs, and then make it fresh. Okay, so we're rotating sleeve C, which is right here, and we're gonna be rotating sleeve A higher. It's going to start from gear A higher point, I need more space here, there we go. Gear A higher point starts from here and ends at gear C higher point, or gear C top point, right here. Bam. Compile, preview, everything is aligning beautifully. Event graph, of course, we need to get these into the actual game when it's being played as an action, like that. This is getting a little bit on the long side. Save. Yep. Yep. Alrighty then. So we have those. We have the sleeves. Sleeve A, B, or sleeve B, and sleeve C. Okay. By the way, there are ways of how you can make this much cleaner, and that is called functions. Functions. Using functions. Think of functions as basically clusters that you have in Grasshopper, right? It works exactly the same way. You can compact everything into one node and then access that node from a separate tab. So those are functions. But for the sake of, I mean, this is a little bit more messy, but I feel like for beginners it's better when you see everything on the same screen and less tabs. Let's do one more. Let's do some sticks. So these two, I feel like all we need to do now for this, or rather let's do, they should be aligned with that, right? So we need to find the origin point again. I'm just gonna use the same script. I'll show you the power the power of Grasshopper. So I'm just gonna hold that. I just need those two, right? Oh yeah, and the stick as well, of course. Isolate. There we go. Oh, I don't need this. Or do I? I kind of do, because I want the alignment right there. So I'll use that point, and now I don't need this. This curve can go away. I will reference these two in my Grasshopper script as set multiple geometries, because it's two of them. Hide those. And then I will try to figure out the direction. Okay, so origin is easy. Point A. set 1 point. That's the point A. Okay. Point B needs to be actually here at the end of the stick, right? Because that's the looking towards direction. So that's the length. That's point B. I chose to set multiple points. I assume it was set. I'm not sure. And then point C is going to be here. Bam. Should be fine. Clearly, right? I mean, looks okay. So we just bake it. Insert. Bam, bam. Wonderful. Wonderful, wonderful, wonderful. Export. Actually, it's going to export as two separate objects. I don't want them to be separate. Can we not have them separate? Like it's going to import the top plate and the stick separately. I want them to be one object. So I'm going to mesh them. And Grasshopper preview is in the way, so I'm disabling that. So I'm creating a mesh from these two, and I'll join them into one mesh, and then I export them as who remembers which stick was which? I sure don't. It's just stick 1. Okay. Save. Replace. Back in here. All we need to do now is just right click on it and re-import. Voila. Easy as that. Press play. Press F. It wiggles. It intersects. As it should. But it wiggles. Yay. Okay, so that works. One last thing. Stick 2. Because now, okay, just to show you the thought process now. We saw that it wiggles, right? So I can actually, first of all, I need to check where does it wiggle? Or sorry, where does it intersect? Left-hand side. Okay, this area right here. Okay, so I can just simply take this, move it a little bit forward, move it a little bit. I lost where I am. Ah, yes. Ah, yes. Move it a little bit to here. And now it shouldn't intersect, right? And then all I need to do is just take these two again, set multiple geometries. Insert key to bake them out. Mesh, delete, join, export as a stick, save, yes. Back in Unreal, re-import, offset, happens. Easy as that. And now there shouldn't be an intersection. There we go. Yeah. Okay, so that works. Let's get another stick in here. This one, show selected. Okay, that whole plate and its anchor point is gonna be right here. And we will still need that. Okay. And I just create one point here because that's, you know, that y-axis, and that is going to be its, give it to me. There we go. And that is its, I can do it, x-axis, all right? And I'm actually going to just create another, because this is like stick 1, right? Stick 1. And this is gonna be stick 2. And I will reference multiple geometries. Point 1, set 1 point. Difficult to reach wireframe, easy to reach. Point 2, point 2 easier to reach in shaded. Bam. Point 3. No, point 2 is this. Yeah. Point 2 is a long set 1 point. There we go. That's point 2 or point B, and point C is y-axis, so that is here. Okay. Scribble. That is origin. That is X, and that is Y. Okay, so that I don't forget. Right, so this should work. Now I just export. Oh, sorry, I just insert. There we go. Why is it upside down? I think Y is in the wrong position. No, not a big deal. Not a big deal at all. We just take the Y point and we position it, or we move it from here, to the other side of the joint. No need to re-reference anything. None at all. It's already, you know, it remembers. It remembers. Okay, so we have that going. Now we mesh, delete, export, stick to, save, yes. Oh man, it's so nice when you, okay, and then we re-import. It's so nice when you have everything, there we go, already kind of set up. Then you can start feeling the how nice the iterative process is. You know, when you just kind of are going through design iterations. That is why we're kind of bleeding here when we're creating all of this relationship between the elements. And then suddenly, you know, you get the prize when you just change the geometry, you re-import, and bam, everything always works because you spend the time setting it all up. Don't you okay, intersects. Hey, but that's pretty cool. I like that. I'm gonna look at it from the top. Nope. Damn it. I wanna jump on it. Can I? Yeah, I can. Sweet. Yeah, so there's an intersection happening. We'll need to fix that. But hey, this seems to be working quite nice. Okay, I'm gonna go to sleep. Good morning. Okay, let's keep going. So first thing that I have noticed when I turned off the recording was that the audio, every time Rhino is turned on, audio is messed up. And I have tried to replicate the problem and I was unable to, so maybe after restarting the computer now it's fixed. Who knows? You're listening to this, so hopefully this is not starting to crack like crazy. Anyway, so that is one thing. Second thing is I have also spent a little bit of time just detailing this, hide that, detailing this geometry right here, creating Boolean difference in the wing to make some space for the intersection not to happen. Also a few frames here and there. I don't really need that as a mesh, so I'll just sell mesh right now, just hit delete, so that I have this quite clean. Back in here I have just simply re-imported it as stick to, and now we have something like this. There we go. And there's no intersection happening between these two plates now. So we're happy. Let me actually, one second. Let me do this. Whoop. So that we can investigate it from up close. There it is. All right, so this works quite well, this works nicely. Now it's time to import the static portions of the geometry and then kind of start working on the outer design. And of course the outer design portion will be done as a time lapse because ain't nobody got time for just looking at me model. But importing, I think, is an important portion of this course, so I'm going to show that in real time. Basically, if I hit show here, I have my frames that are here, and I have my panels, and that's basically it. I have everything else kinda already in there. So let me hide the gears, those will not be imported. And maybe we first can export the panels. So for glass, I will select all of the panels of the glass, and you can do this in two ways. You can either export it as separate pieces, or you can export it as one piece. So in this case, I'll export it as one chunk. So I need to convert them into a mesh. Wait, 25 surfaces. That's weird. 1 second. Cell objects, isolate. So what do we have here? 25 surfaces. Cell srf. Oh, okay. So there is a bunch of just failed boolean, not boolean, but failed chamfers, which is fine. At this scale, we don't need them, so I just delete them. Maybe I should explain this better. We have these chamfers here in some places where I chamfered the geometries, and in other places it fails because Rhino's chamfering filleting system is not that great when it comes down to the radius of the fillet being too high or to make a corner. It's just going to fail. Which is fine for this particular example, so I'm not going to start fixing it. Right. We mesh this and we make it into a single mesh. Yikes, that's a lot of polygons. We don't care. Cell mesh. We lock it. Sorry, we don't lock it. We join it. We join it into one mesh. And we then, I believe we can just simply export it from the origin. So we just simply export. We don't need to do any custom origin for it at all. And I will just find my gears for tutorial, motion builder, and I'll just name it platform glass, like that. Hit save. We're happy. Now in here, let me just quickly navigate to it, drag and drop, import. It's a little bit more heavy. Maybe I should. Oh wait, why is it 3? Let's see. The errors don't matter. Let's see what it imported. Platform glass, plastic material, and that's it, right? Yeah, okay, so it came with its own material. We're fine with that. And if I check it, you can see that it imports blue, and that's because I have that blue material used in Rhino. Transparency didn't come through, which is fine with me. So let's edit the blueprint and let's get the platform glass in there. So under my default scene root, I will just simply add static mesh platform glass, just like that. And it's added. Why is it added here? Well, it should be added here. One second, I need to think. So the center point is -485. Oh, it simply needs to be scaled in y direction by -1. And that's because the left-hand side, right-hand side coordinate system of Unreal Engine versus Rhino. Remember? Do you remember? We already talked about this multiple times. X, Y, Z like so, while in Rhino, X, Y, Z, X and Y are flipped. So it's basically Y is in the negative, right? So it's freaking out. We're now should be okay with this. Compile, save, play, step on the glass, seems to work. F, yep, gear spin, everything works. Nice. Okay, awesome. And then the frames, right? So I guess for the frames, I'll do a time lapse because yeah, let's not waste time. Alright, so here we go. Here's the detailed structure. Well, I say detailed, but it's actually just bare minimum of what I would consider to be, you know, detailing. But we do have our metal beam structure with some panels attached to it. Nothing intersects when it's running. Everything seems to be going correctly. So that's that's what we're aiming for, right? With this, at least at this stage. I would personally, I mean, I wish I could spend more time on this modeling, maybe 10 more hours, something like that, to really get it in there in terms of the quality, but this will do. Also, I noticed that you can make these kind of incisions here. That will always fit properly because the structure is always aligned with the column that it's being held by, right? So that was a nice find. Anyway, we have ourselves a form, right? A form that we can continue on working with. So in terms of the next steps, we still need to do some materials. And then we'll call it a day. We'll say that this structure is finished. Maybe I'll do some virtual reality testing. I kind of want to. So that's gonna be at the end of the video. All right. So materials. Currently we have two materials, the material 2 and plastic. We will not be using any two of these. We will be using a separate one. So first let's do the metal bits because that's going to be easy. I will go to the Quixel bridge. You go to, I believe it's under window, right? Somewhere. Yeah, there we go. Window, Quixel bridge. This one I have it docked here. And Quixel Bridge is basically just has a bunch of assets that you can use and download and then use in your scenes. And also it has surfaces, which are materials, and you can just get any kind of material that you want. So I'm just gonna go for, where's our little metal? There we go, metal, bear, and we'll just go for something very simple, iron maybe. There we go. Asks me to sign in, so let's see if I will need to show something. Let me do this. Hi. I'm gonna be typing in my passwords. It's your Epic Games account, by the way. And if you use your Epic Games account, you get damn it, wrong password. If you use your Epic Games account, then you get all of these. Damn it, wrong password again. All right, so I remembered my password. So if you have your Epic Games account, which is free to get, then you get the Quixel Bridge, all of the scans, all of the materials, all of the textures, plants, and whatever in it for free. So it's a very good value. In my opinion. So back to surfaces, back to metal. Bare metal, which one was it? Iron, right? Yeah, there we go. So iron is already downloaded. I will just click on export media quality and it's just going to be placed right here. Simple as that. Looks weird. No, it's fine. That's fine. Okay, so that's where my material is. I'll come back to viewport. And now I'll just use iron. Okay, so I'll go to my stuff, my geometry, and here I'll just start slapping on the iron material onto everything that I want to be made out of iron. For instance, this frame. You don't really change the materials for the frame here because you're basically overwriting the materials of the frame in the blueprint right here, right? So in the blueprint, if I choose platform frame, the material is set right here. So I can just simply iron, bam, and now if I look at it from below, it's gonna lag a bit. Come on. There we go. You can see that it's now all shiny. So that's the plan with all of these. So we have the frame here, then stick, we don't mess with the sticks for now. We do change gears. Iron. There we go. What else? Gear A. You can choose multiple elements if you just hold the is it shift key? Let's see. I need a sleeve. No, it's control. So if you hold down the control key, you can select multiple elements here. That should help. Like that. And then we get the sleeves in there. Nope, we don't. Okay. Perfect. And iron. Okay. Neat and shiny. Right? Right. I still don't have sleeve. a higher, this one. Ew. Okay, so this part is because the stick also contains the sleeve geometry in it. So I'll need to export the stick element without the sleeve geometry. That's not a big deal, but yeah, that seems like it's gonna be a-okay. And now a little bit more tricky thing is this glass looking thing, right? So I want this to be slightly transparent. Also, let's just take a look at it here. Yeah, it looks nice. I wanted this to be slightly transparent, right? Don't mind that. So for that I need to get corresponding material from here, and I believe, if I'm not mistaken, this library does not have like glass and semi-transparent materials. So we need to create our own, which is fine. Let me show you how you can create your own kind of semi-translucent glass material. So I'm going to be messy here, and I'm just going to create under my stuff, I'll just create a new folder and call it my materials. You can create the folder anywhere and have it materials and have its name be anything. And in here, in this folder, I'll create a material and I'll call it glass. Well, it's not glass, it's like transparent. Yeah, transparent material. Okay. So that's going to be our transparent material. I'll double click on it to open it up. And here we have a bunch of different settings. And you can see below it says substrate is not enabled. Substrate is a new type of material which came with Unreal Engine 5.3. Not type, sorry. It's a new engine for material creation, manipulation, and calculation, right? That came with Unreal Engine 5.3. That is, or 5.2. That is, to my knowledge, quite powerful. So first thing that we do is we enable substrate, because we always want to use the newest toys, right? So let me close this material real quick, and instead let's go to the settings right here. Let's go to plugins, and let's find substrate. Ah, I found it. Okay, so you don't do that. Substrate is not a plugin. It's a setting, right? That you need to enable. So you go to settings, project settings, and here under project settings you search for substrate. Substrate materials, enable that, tick mark that. Substrate is experimental, blah blah blah. We don't care. We don't really need opaque material or rough refraction. No, we don't really need that, I believe. If we will need those two, we will enable them later down the line. But for now, just tick mark that, and it's gonna ask you to restart. We will hit the restart button. Okay, there we go. So now it's restarted, and now we can start using substrate to create our glass, or fuzzy semi-transparent glass, if you will. So I'm going to double click on the material again to open it up. And now we can see that this menu is a little bit different. It's a little bit changed. So substrate already gives you the statistics for the material. Right now there's nothing fancy going on, so the statistics are a little bit boring, but not a material tutorial, so let's just kind of quickly jump through this instead. I will not be diving too deep into it. First things first, substrate Unreal Engine 4 default shading. Note that is not going to be sufficient for us, so I'm going to be deleting it. Instead, I'll be right clicking and choosing BSDF, substrate BSDFs, and I'm going to use slab, substrate slab. You can see much more settings. We get much more settings. I will only be talking about the settings that we actually need. Then let's connect the output of the slab into the material output here, transparent material output, like so. So this is what it's going to be outputting, the node that is responsible for actually outputting the material. And now let's start changing some settings. Make sure that you don't have anything selected on the screen, so just click somewhere on the empty space, and then you'll have your menu here where you have a bunch of different tabs. Under Material tab, the blending mode should not be opaque, but rather it should be, where is it? Where is it? Translucent. Translucent colored transmittance. That's the one. So we choose that. Right? This will enable us to create transparent materials. Next up, we will want to use refraction. So maybe you will want the possibility to change to bend the light as it travels through the material. So for that, we will need to search for refraction. Refraction method. Instead of none, we choose index of refraction. There we go. Delete that. And now we have this input here, refraction, for index of refraction, as well as all of these inputs here. Basically, for this to work, we need to be physically accurate, or else it's gonna be a mess. So the first step is diffuse albedo. So the diffuse albedo color is going to be black. And to create a color in Unreal Engine 5, you create a vector. So RGB becomes the XYZ of the vector, right? So if you just type in 3 vector, constant 3 vector, like that, you'll get this node right here, and you just, by default it's 0, 0, 0, meaning it's black, so you can just kind of connect it to the diffuse albedo color here, and your material turns black. Then we want to control the roughness of it, so how shiny it is, and for that I'm going to be creating a scalar parameter. So we'll just do scalar parameter right here. I will name it roughness. I will change its settings, so the default value should be, make sure that you have this selected to be able to change the settings. The default value should be like 0.1, so just slightly rough, maybe even less than that. Then the minimum slider should be 0, maximum should be 1. The roughness should never go beyond the bounds of 0 to 1. And then we just simply connect it like that. Okay, that's done. Now let's create another scalar parameter for refraction, index of refraction. Right click, scalar parameter, name it IOR, and this one is going to have the default value of 1.4, minimum of 1, maximum of, you can go for 10, sure. On Google, if you type in IOR table and go for image search, then you'll get index of refraction for all different types of materials. Okay, we just connect it like so, right? So now we can control both the roughness and the refraction. It's still black. Why is it black? Well, that's because we need some subsurface scattering for it to work. Subsurface scattering is basically a calculation method of how you calculate the light bouncing inside of the material, right? So human skin is the best example of that. You know, when you're holding, let's say, a light bulb, you can see, you know, your skin being kind of shining through in a red color, right? So that's or wax, I guess, is also another example. Marble is also an example. Anyway, what we need is this SSS, subsurface scattering, and we need the MFP. MFP stands for mean free path. I will not be explaining that right now, mostly because I also only kinda know how that works. Okay, but let's just search for substrate, or we can just go for mean free path. Yeah, substrate transmittance to mean free path, like that. Connect MFP to SSS MFP, like that. And then here you can choose what's the skin color, so to say, of your material. And here you can choose what's the thickness of your material. So for the transmittance color, I'll just create a constant 3 vector, just like that, just like we did here, connect it. But this time around, I'm going to change it. So I'm going to select it, go to the left-hand side, and here you can change the color. And I'm going to change it to be slightly towards blue, ever so slightly. Wow. Wow. I think once we add the thickness, it's going to be okay. It's going to be fixed. Okay, speaking of thickness, that does need to be a scalar parameter. I'll call it thickness. And here we're just going to give it like a, I don't know, 2 centimeters. Let's go for 2 centimeters. So default value is going to be 2. Minimum is going to be 0. Maximum, I think like 20. Something like that. So 2, 0, 20. Connect that. Yeah, this seems a little bit more reasonable. This should be a bit brighter, I think. Okay. Let's try this, right? So now we save the material, and then from it we need to create what's called a material instance. So let me close that. This is our material, and I'll right click on it, and I'll choose create material instance, which is that. And here I'll just say glass, or how do we call it? Transparent 01. Transparent 01. That's gonna be fine. Then you operate with the material instance. You never mess with the material, because you can have one main material and then you have variations of it. So all of the variations of the main material are the instances, right? So imagine this, you want red glass, you want blue glass, you want green glass. For that, you don't need 3 different materials. No. You just use one material where the color is a variable, and then you create 3 instances, right? So remember all of those scalar parameters that we were adding? Now in this instance, they are here, IOR, roughness, and thickness. And I can literally tick mark them to make them active, and then I can mess with them, right? 1.4. And I can mess with the roughness and make this a little bit more roughy and so on, right? So that's the beauty of this, right? Of this approach. Let's apply this. So I'm going to take this, or actually let's close, and then I'm going to go to our blueprint, edit it. I'll go to the viewport, select the glass, and here I'll just choose our transparent material instance, or transparent 01. There we go. And now that's our glass. And you can see how weird it is. And it's weird because of the the different angles, and also it seems like it's breaking a little bit. That's fine. That's fine if it does. Let's take a look at it here. I think the magnification is a little bit too much. She seems to be doing quite well though. So let's mess it up a little bit, right? Back in here, now if I change the material, anything about the material, it's going to change here immediately, right? And you can see that it's not perfect, right? There's still mistakes that are being made. This is still much better than what we used to have, trust me. But it's still not perfect in terms of reflections. This is where game engines kind of break down. It's when they need to calculate these kind of complex reflections. I feel like for this we can get rid of the IOR and use 0 for it. And or maybe much lower value. Yeah, because you see this is not accurate. If there are anyone who's watching this who knows what's up and who knows how to make it more accurate with the tools that we currently have, you know, let me know. Let me know. Is it the geometry? Is it the materials? I'm not sure. But in this case, IOR cannot be used, which is a shame, but fine. That is fine. Okay, we take a look here. We run this. It's all working properly. We're happy. Okay, back in the material tab, if you want to change the color of the material, you can always go into the actual like master material and change the color there. If you want it to be more interactive, you can right click on the constant color, not the diffuse albedo, but the subsurface scattering color. You can right click on that, convert to parameter and call it color tint. Save that. And now under the material settings, the instance material settings, I will have color tint as a variable that I will be able to change. And technically this should change, but yeah, it kind of does. It kind of does. You do need a pretty active color. So for that, we maybe reduce the thickness. Whoa. 0.1, 0.2, yeah. So you mess around with the thickness and everything here, and eventually you'll arrive at a pretty decent output. Okay, we have ourselves a pretty, you know, it's okay. Could be better, but this is good enough. Glass. Let me go into my blueprints. No, into the geometry, and I'll just explain one little thing before we continue. The glass, sometimes substrate materials, yeah, you can see it makes the glass a little bit jagged because it does not play that nice with with nanite, right? So the glass material does not play that nice with nanite. You can clearly see that if I look at it now through the wireframe view, this is how it looks like, and this is nanite remeshing it as I'm moving it in closer or further away. And then here, if I change to instance, sorry, not instance, transparent 0.1. Actually, that's not that bad. Oh yeah, that's because I have already done that. You would see something closer to this. There we go, to a low polygon, low resolution mess, right? So to fix that, there are two ways of how you can do it. You can either disable nanite for everything that is transparent, and that is what we used to do, or you can go in here and for the fallback target, under nanite settings, fallback target, relative error, and here you just choose relative error of 0.02 or something like that. Hit apply. There's two applies, keep that in mind. Hit the top one. And now this is, you know, good enough, correct. And if we move away, it does not really, yeah, nanite is broken with these materials. Anyway, this is good enough. We can continue. So the next step is to actually just get the sticks separated from the, like get the panels and the sticks separately, right? And get them into our scene. So back in Rhino, I'll enable stick 1, which is this bad boy right here. And I have already separated them like so. And for all of these geometries, I will just mesh them, you know, same old, export. And this is gonna be our stick, if I remember correctly, yeah? There we go. And now I will show selected. Nope, my bad. Give me a second. That needs to hide. Okay. So I will. Don't need that mesh anymore. But I do need all of the glass panels. So stick 1, all of the glass, mesh those, cell mesh, join. So now all of the panels are one single mesh. Export, and that is going to export as stick glass, save. And I'll repeat the same procedure for stick 2. So those of you who haven't followed, now this is gonna be your chance. Disable the glass, mesh all of this, hide, export, that's stick 2, save, yep. Hide, not hide, delete actually. I think, show, yes, that's good. And stick to glass, select objects, mesh them, cell mesh, join, export, stick to glass. Easy, okay, delete. So Rhino portion is kind of done. There's of course UV unwrapping that, you know, we didn't take care of and so on, but that's not part of this tutorial. Okay, let me re-import stick and stick 2. Now they are going to import without glass. Re-import. While they're doing that, let me get stick 2 glass and stick glass, both of these in here. Import. Bam, easy peasy. The framing looks kind of neat, ain't gonna lie. And then for the glass, we will just simply add them in. So stick 2 glass, I will select it here, and then in the blueprint, I will find where the glass, where stick 2 is. There we go. And I'll just attach the glass to the stick 2, so it moves together. So yeah, add, bam, just like that, easy peasy, stick 2 glass. And then for stick 1, I'll just stick, I will select stick glass and attach it there. Add static mesh, stick glass, bam, gets attached. Okay, so now stick is the parent of stick glass and stick 2 is the parent of stick 2 glass. And I can of course use now the materials. Transparent 01. Is it transparent? Yes, it is. Perfect. Transparent 01. Perfect. And now for the frames, Oh, these are not. Okay, I forgot to add materials to these. That's fine. We will quickly fix that. So that is gonna be iron, was it? Iron. Perfect. Okay, how does this look like? Yep, starts looking promising. Compile, save, play. Why can't I get in? Oh, I know. That's because these two guys have collisions. The collisions are not solved for, oh, you don't see it, for these two guys, for the glass. So I will right click. I need to navigate myself. Let's go here for now. I'll right click, asset actions, edit selection, property matrix, find collision, project default. And instead of collision complexity project default, we use complex collision as simple. Save. And now this should work. Yep, I can just kind of walk around these. Okay, so that kind of works. That is that's what I want to see. I'm not sure if I like the whole transparency thing. I think it's too transparent. So I'm going to mess around with the material a little bit more to get it to fit with what I want to see. So maybe roughness can be a little bit higher here. And then IOR, or rather, no. Let's keep the roughness low. And instead, I kind of want the top panels to actually just have their own material. So I'm going to find one in the bridge under surfaces. Definitely not wood, right? That would be weird. Plaster, gravel, coal, bark, asphalt, concrete, metal. We can do painted metal, why not? You know? Corrugated sheets. If you're doing corrugated sheets, you'll most likely need to work out the UV mapping. Anything that has a texture, you'll need to figure out UV mapping. I can show you how it would look like without UV mapping. So let me export it and let me get it in here, and I guess it's gonna be called corrugated metal sheet. Yeah, you can see that the mapping is all weird and kind of messy. Actually, it's not that bad. I feel like we can work with this, even though the alignment is incorrect. But let's try working with this. So for the corrugated metal sheet, under Megascans, under surfaces, there we go. This bad boy right here. I believe that there's a way of how we can change the tiling of it to be a little bit more of our what's the word? To be a little bit more in scale to what we're trying to do. So for tiling offset, I'll tick mark that, and here tiling X, I will just say 2. So that's gonna be 2 times. Can we do 4? 4 is a little bit too much. Something like that. Let's press play. Take a look. Can't get into my structure anymore. Yeah, that works. Ah, no, I got stuck. Okay, so that works. That works. We're happy. We're done. We're done. That's our structure. That's the end. Okay, I just wanted to move a little bit slower. So that's gonna be probably the last thing that I do. So length should be 20 seconds. Expand that. This point should be at 20 seconds. So 2 times slower, compile, expand that again. That feels like it should be even slower, right? Yeah, let's make it even slower. And print, don't need to print the string anymore as well. So let's do 30 seconds of animation with this point being at 30 seconds. Yeah, there we go. Now we can actually appreciate it. Okay, we're done. Thank you for watching. I might do a separate video on the second channel just investigating this with my headset, but a virtual reality headset, but in terms of 3D kind of analysis with a character, that's all we need. Task 3. Task 3. Okay, I'll see ya. Bye.